Okay, how you guys doing? Hopefully you're doing well. About ready to start section 4-2 for FST. Just so you guys know, we only have, after this section, 2 more sections of trigonometry. Then we'll get into the functions and statistical part of this class. We'll just get through section 4-4, then we get into the other stuff. So the last few sections of trig. So section 4-1, if you remember, we were solving right triangles. The rest of the next 2 sections, we're going to be solving non-right triangles. So you guys know a right triangle has a right angle in it. Non-right triangles do not have right angles in it. So again, solving a triangle, what that means is they give you some information about a triangle. You need to fill in the rest of it. There's always 6 parts of a triangle. 3 sides, 3 angles. So they'll give you 3 of the things. You need to find the other 3. So that's what it means by solving a triangle. It's finding out the lengths and measurements of all the angles and the lengths of the sides. Okay. So again, in order to solve a non-right triangle, we can't use the trig functions that we've been using because, I mean, like sine, cosine, tangent, that deals with opposite, adjacent, hypotenuse. Hypotenuse, you know, it has to have a right angle. It has to be a right triangle. So we're going to be dealing with triangles that are not right triangles. So we got to do something else. So section 4-2 deals with something called the law of sines. Okay, and I'm going to derive. That means create. I'm not going to not create it. It's going to show you the creation of the law of sines formula. I could just say here it is, but it's a very simple process of coming up with this. I think it's just important that you guys see this. I'm not going to make you recreate this on a test, but you do need to memorize the law of sines. It's a pretty simple formula to memorize. So let me give you this, and then I can actually use the law of sines and use the law of sines again to solve non-right triangles. So if I was to give you a triangle such as this, okay? And we'll say this is angle A, angle B, and angle C. Remember, you always denote angles with capital letters. So, and if this is angle A, side A, lowercase a is opposite it. Here's angle B, so opposite is side B, lowercase b. Angle C, little c over here. They look about the same size, but oh well, I make this one bigger. Okay, all right. Now I'm going to do this. This is not a right triangle, but what I could do is this. I'm going to drop this straight down, make a perpendicular, which makes it into, instead of one big triangle, 2 smaller triangles, okay? And they're both right triangles. That's a right triangle and that's a right triangle. So if I was to ask you, for example, the sine of capital A, okay? And I'm going to label this H for the height, okay? Sine is opposite, and we're talking about this smaller triangle. And I can use sine on this one because this is a right triangle. Like, you don't use the trig functions when it's a right triangle, okay? And I broke it up into 2 right triangles. So sine is opposite, which is H, over the hypotenuse. We're talking just this little triangle. Opposite is H, hypotenuse is C, so H over C. I'm going to do the same thing over here. I'm going to find the sine of capital C. Opposite, we're talking about this triangle here, is H over the hypotenuse is A. And I'm going to clear my denominators. I'm going to times this by C and times this by A. These C's cancel, these A's cancel. If I do that, I have capital C, or actually, let's show you lowercase c. Lowercase c is, that's supposed to be little c, sine of A equals H, and little a sine C is H. So if H equals this and H equals that, these equal each other. Okay, H is this, H is that, this is that. So I'm going to write little c sine A equals little a sine capital C. And just for fun, I'm going to divide each side by little a, little c. Okay, whatever I do to one side, do to the other. These little c's cancel, these little a's cancel. So we're left with sine of capital A over little a equals the sine of capital C over little c. That's 2/3 of the law of sines, okay? The law of sines is the sine of capital A over little a equals, this is the sine of capital C over little c. I said that's 2/3 of it. You can probably guess the other third of it. The other third of it is the sine of big B over B. Big B, that's my wife's favorite place to get her coffee, by the way. She goes there every single day. Equals the sine of capital C over little c. That is the law of sines. Am I going to make you recreate this? No. Okay, but I just thought it's important that you see where this came from. So what about the law of sines? This will help us solve non-right triangles. Okay, so I'm going to get rid of this right here. We just want to, again, just show you where this formulas came from. Okay, so we look at, let's look at question number, we're going to start on question number 9. The assignment itself, just so you guys know, is problems 9 through 36. We'll do, there's 28 questions, we'll do 14 together. You guys do 14 on your own. We're starting this also. I'm going to post this video on Thursday, January 7th. We're going to have a homework quiz over on Tuesday, January 12th. So that gives you about 4 or 5 days to work on this. So we look at question number 9. All right, they give us a triangle. The first thing I want you to do on every one of these is draw a triangle, okay? So we have 95 degrees, and we have 45 degrees. We have capital A, little a, and 5, okay? So we still need to find, and we have little b over here. We got to find capital A, little a, and little b. Okay, I'm going to find capital A first because that's the easiest of all. You could do that back in middle school. If we have two angles of a triangle, the third one, we just add these up, 95 and 45, add up to 140. So this has to be 40 degrees because all three angles, you know, have to add up to 180. Okay? All right, so what we're going to do is this. Now you might be wondering, well, you have 3 parts here. Which parts to use? Here's what you do. You use the one that you know both of. Do we know both of this angle on this side, or this angle on this side, or this angle on this side? Well, we know these two, okay? We know this right here and this right here. The sine of 95 degrees over 5 equals, I'm going to find capital A next. I could find, it doesn't matter what I find next, but I'm going to find, I already found, take that back. I'm going to find little a next, not capital A. So the sine of 40 degrees, we know it's 40 degrees, over little a. And then we cross multiply and divide. We take this times this, 5 times the sine of 40, and then divide by the sine of 95 degrees. That equals little a. By the way, you're going to need a calculator for these. Okay, and make sure you're in degree mode. We're done with radians now. So we type in 5 sine 40, enter, divide by the sine of 95. And if we do that, we get about 3.2. So little a is 3.2-ish. It's like 3.226, okay? And then we still need to find little b, okay? So I'm still going to stick with these two. I could do these, but I shouldn't because that's an approximation. This is exactly 5. This is not 3.2, it's 3.266 or something I said. So we'll stick with sine 95 over 5 equals, I want to find little b, so the sine of 45 over little b. And again, we cross multiply and then divide. So we're going to take 5 times the sine of 45 degrees, divide by the sine of 95 degrees, equals little b. So we type in 5 sine 45, and then divide by the sine of 95. And you get about 3.5. So b is about 3.5. Now, this is done, but I would encourage you to do one more thing. You don't have to do this, but you always find the biggest side across from the biggest angle and the smallest side across from the smallest angle. So this is the biggest angle. Is that the biggest side? Yes. This is the smallest angle. 40 is the smallest. Is it across from the smallest side? Yes. Did that prove that we did it right? No. But if the biggest side is not across from the biggest angle, or the smallest side is not across from the smallest angle, you messed up somewhere. It's definitely wrong, okay? So this may be right, and I think we did it right, unless I punched in something wrong, okay? Number 11. Let's draw our picture again. So we have little a, little c, 85, 50, and b, and little b. So again, we're going to find, I'm going to find big B first. These two add up to 135. 85 and 50 is 135. We take 180 because the triangle is 180 degrees minus 135 degrees. You do that, you get 45 degrees. So capital B is 45 degrees. So what do we know both of? I've got to have a side here, don't I? That's 3 over here. Okay. Otherwise, there wasn't enough information. Okay. So we know both of these. So I'm going to say the sine of 45 over 3 equals, I'm going to do little a first. So the sine of 50 over a. It doesn't matter which one we find first. So we cross multiply and divide. So we take 3 times the sine of 50, divide by the sine of 45, equals a. Okay, and I'm going to punch that in a second here. And then if I want to find, well, we'll type it in right now, what the heck. So 3 sine 50, 3 sine 50, divide by the sine of 45. Okay, so we get about 3.3. Okay, so a is 3.3. And then we need to find out what do we gotta find? Little c, so we're gonna stick with these two. Again, I could use these, but you shouldn't because that's an approximation. These are exact values. So it's better to use exact values because it's not approximations, okay? So the sine of 45 over 3 again has to equal sine of 85 over c. So we cross multiply and divide again. So 3 sine 85 divide by the sine of 45 equals c. So we type in 3 sine 85. 3 sine 85. Enter, divide by the sine of 45. And we get about 4.2. C is about 4.2. And again, biggest angle, biggest side, yep. Smallest angle, smallest side, yeah. That looks good. Okay? Again, that doesn't prove it's right, but if it doesn't work out, then you definitely made a mistake somewhere. Let's look at number 13. Question number 13. Okay, so we got our picture here. Okay, so we have big C and little c. We have 45 degrees and 40 degrees and A and 7. So, okay, we add these up. We get 85, subtract 85 from 180 and you get 95 degrees. Okay, I'm not showing my work there because I really don't think you need to show your work. Okay, so I know both of these two, so I'm going to say the sine of 45 over 7 equals, I'm going to find little a first. It doesn't matter if I find little a or little c first, doesn't matter. But so the sine of 40 over a. Again, we cross multiply and divide, so 7 sine 40 divided by the sine of 45 is little a. And I tell you what, I'm going to write these out, I'm going to type them in at the same time. And then when I want to find little c, I'm going to stick with these two, the sine of 45 over 7 again, equals the sine of 95 over c. So we cross multiply and divide, so 7 sine 95 divided by the sine of 45 equals little c. So we just type them in at the same time, well, one at a time. 7 sine, I'm doing this one right here, 40, darn it, divided by sine of 45. We do that, we get about 6.4. A is about 6.4. And 7 sine 95 divided by sine of 45. And you get about 9.9. Okay, biggest angle, biggest side, yep. Smallest angle, small side, yeah. And these two are close, and they should be because those two are close. Okay? All right, number 15. Okay, 15. Oh, this one won't be that bad. This one actually quicker. And it's because of the numbers I use. 100 degrees, 40 degrees, A, C, and 2, and capital A. So I'm going to find capital A first. This is 140, so that's got to be 40 also. This is not a right triangle, but it is an isosceles triangle. Okay, these two angles are the same. If you remember from geometry, and if you don't, you just have to do it the way we've been doing it. But if you remember, these two base angles are the same, so these two sides right here are the same. So A is 2. You could do it the way we've been doing it, but it's going to be 2. That should be an easy one, okay? We got to find out what C is, okay? And be careful. Some students say, well, can't we use the Pythagorean theorem? We have two sides. We just need the third side. That only works on a right triangle. This is not a right triangle, okay? So I got to find capital C, so I'm going to use the sine of 40 over 2 equals the sine of 100 over C. So cross multiply and divide, 2 sine 100 divided by the sine of 40 is little c. So we type in 2 sine 100 divided by sine of 40. Do that, we get, ooh, that's not good. What did I do? Something's not right. Let's do it again. 2 sine 100, 2 sine 100 divided by the sine of 40. That's better, about 3.1. So about 3.1. And that's the biggest angle, that's the biggest side, so looks good. Okay. Also, I lied to you guys, okay? I'm gonna make this quite a bit easier for you. I said we're gonna go all the way to number 36. We're only gonna go to number 24, okay? We're only going as far as 24. if it really interests you, you can look at 25 to 36. It's kind of interesting. If you look at the instructions on your worksheet, when you get to 25 to 36, they talk about, so sometimes you could have one triangle or two triangles or no triangle. Okay? They might give you information that it's possible to have two right answers, and you need to do both of them, or you could have no triangle that fits the information. So I'm actually going to skip over that, make it easier on you guys here, okay? So don't worry about 25 to 36. We're only going to go as far as number 24. So number 17. The only difference between 17 and 24 from what we just did, there's no picture, okay? So the first thing we do is draw a picture. We draw a picture, okay? And when I'm drawing these, I'm not even going to look at the information yet, okay? I always draw a triangle that looks pretty darn close to equilateral, okay? The reason is, it's really simple to put information in there. If you look back at your worksheet, when you look at number 14, that's really hard when you look at that picture to put information in on number 14 because it's such a short, flat triangle. It's hard to get the information in there. So when I do this, and what I want you to do is let's always put A on top, B to the left, and C to the right, okay? So just so we're all on the same page here, I'm always going to put A here, B here, and C here. I'd like you to do the same thing on your homework, okay? So A is 40 degrees, B is 20 degrees, and A is 2. Little a is 2. Okay, so let's find big C first. These add up to 60, so this has to be 120 degrees. Now again, this is very, very poorly drawn, but that's really okay. I mean, this is an acute angle right here, but it's 120 degrees. So I mean, it should have been an obtuse angle. It's okay. This is not art class, okay? All right, so we know both A's. Sine of 40 over 2, sine of 40 degrees over 2 equals, we got to find little c and little b. It doesn't matter which one we find first. I'm going to do them alphabetically usually. So the sine of 20 over little b. We cross multiply and divide. So 2 times the sine of 20 and divide by the sine of 40. It's going to be a little b. And then we got to find little c. So again, I'm going to stick with the sine of 40 over 2 again. Sine of 40 degrees over 2 equals the sine of 120 over c. Sine of 120 over c. We cross multiply, 2 sine 120, 2 sine 120, divide by the other one, sine of 40. And we grab our calculators, and we type in this to find the two sides. So we type in 2 sine 20, 2 sine 20, divide by the sine of 40. We do that, we get about 1.1, so 1.06. And type in 2 sine 120, 2 sine 120, divide by sine of 40. We do that, we get about 2.7. And these answers look reasonable. Biggest side angle, is that the biggest side? Yes, it is. That's the smallest angle. That is the smallest side. They look reasonable. So unless I typed in something wrong, we did them right. Okay. Okay, getting closer to being done. 19, 21, 23, 3 more to go. Number 19. Again, we draw a picture. So we always put capital A here, capital B here, capital C here. B is 70 degrees. C is 10 degrees, and again, that's really poorly drawn. It looks more like about a 50 or 60 degree angle instead of 10, but that's okay. B is 5. That looks terrible. Okay. And what do we got to find here? We got to find little a, little c. These add up to 80, so A has got to be 100 degrees. Okay, so we know both B's, angle B and side B. So the sine of 70 degrees over 5 equals, I'm going to find little a first, sine of 100 over A. Okay, so 5 times the sine of 100, divide by the sine of 70, is little a. We'll punch that in a minute. Then to find little c, we're still going to stick with the sine of 70 over 5. Sine of 70 degrees over 5 equals the sine of 10 over c. Little c, so 5 times the sine of 10, 5 sine 10, divided by the sine of 70, equals little c. Hopefully it feels like we're doing the same problem over and over and over, because we are. They just have different numbers. So we're talking 5 sine 100, divide by the sine of 70, get about 5.2. And also, just so you understand here, I would type in 5 sine 10, I don't think I've said this yet, enter, then hit divide by the sine of 70. If you don't hit enter, quite often it'll give you an incorrect answer. You do that, you get about 0.9, okay? So smallest angle, definitely the small side, biggest angle, biggest side, yep, that worked. 2 more to go. Okay, 21. Again, we draw our picture. Capital A, capital B, capital C. So A is 110 degrees. C is 30 degrees. And what? Little c is 3. Okay. Okay, so these add up to 140. So this has to be 40 because all three of them have to have 180. We've got to find little a and little b. I'm going to find little a first. I know both c's, so the sine of 30 over 3 equals the sine of 110 over a. 3 times the sine of 110, whatever that is. Divide that by the sine of 30. That's little a. And then we got to find out little b. So we're going to take the sine of 30 over 3 again. Sine of 30 degrees over 3 equals the sine of, we find b, sine of 40 over b. So 3 sine 40 divided by the sine of 30. And we type them in. So we type in 3 sine of 110, enter, divide by the sine of 30. We do that, we get about 5.6. And 3 sine of 40, enter, divide by the sine of 30. We do that, we get about 3.9. Okay, biggest angle, definitely the biggest side, smallest angle, smallest side. Okay. Okay, let me check on this. My computer's falling asleep. Hopefully it's still taping. Yes, it is. Good. 1 more to go. Only 1 more to go. Okay. $23. Okay, so we have, oh, this will be an easy one. A, B, and C. A is 40 degrees, B is 40 degrees, C is 2. Little c is 2. Okay, and these are both 40, those have to 80, so C's got to be 100 degrees. Okay, so, and what's nice again, this is not just a triangle, it's an isosceles triangle. These two angles are the same, so these two sides are going to be the same. Whatever they are, they're the same. Okay, so we got to find little b and little a. I'm going to find little a first, but once I find little a, little b is going to be the same thing. So I'm going to take, I know both of my c's, the sine of 100 degrees over 2 equals the sine of 40 over a. So 2 times the sine of 40 and divide by the sine of 100 equals a. And I'm not going to find out what little b is because they're going to be the same. Okay. So 2 sine 40, enter, divide by the sine of 100. We do that, we get about 1.3. So A is 1.3-ish, B is 1.3-ish. Again, you only have to go through 24. Only questions, 9 through 24, so that's what, 16 questions or so. 25 through 36, you don't need to worry about, okay? Okay, if you have any questions, email me. And again, this assignment, I'd like to start it. I'm going to post this on Thursday, January 7th, and Tuesday, January 12th is when we're going to have a homework quiz over it, okay? Catch you guys later.